right, we're going to be dealing with inequalities today in this video. So an inequality is greater than or equal to, or equal to, I should say, or it can just be just less than. It can be just greater than, or it can be less than or equal to. So greater than or equal to, less than or equal to, we'll have a line underneath. Less than or greater than, we'll have no line underneath. And it'll also be indicated in the graph, whether it's greater than or equal to, or less than or equal to. So in this first problem here, 2/5 x plus 2 is greater than or equal to 6. We're literally going to treat the inequality almost like an equal sign. But in this first problem with the fraction, I'm going to show you how to get rid of a fraction. If you only have one fraction in the problem, you multiply everything by the denominator. 5 divided by 5 is 1, and 1 times 2 is 2. So you get 2x. This eliminates the fraction. But you do have to multiply the 5 to the other two terms. So 5 times 2 is 10. 5 times 6 is 30. And then it's basic algebra. We subtract 10, we divide by 2, and we get x is greater than or equal to 10. When I go to graph, it's going to be on a number line. When it's greater than or equal to or less than or equal to, we fill in the dot. And since it's greater than 10, we draw our line to the right of 10. Here we have a less than, so 3x plus 5, oops, I don't know why that's there. 3x plus 5 is less than 5 times x minus 6. So we distribute. 3x plus 5 is less than 5x minus 30. Now, I'm a big fan with inequalities of keeping the x to the left. So I subtract 5x on both sides, and I subtract 5 on both sides. So I end up with negative 2x less than or equal to negative 35. This is the one change that's a difference between equal sign and inequality. When you divide or multiply by a negative, you have to flip the sign. Okay. Here we're dividing by a negative 2, so the less than becomes a greater than. If you divide by a positive or multiply by a positive, nothing happens to the sign. So in this problem here, when I multiplied both sides by 5, nothing happened to the inequality. But here, we're dividing both sides by a negative 2. Negative 35 over negative 2 is a positive 35 over 2, and the inequality gets flipped. Since it's a less than, this is an open, or I'm sorry, since it's a greater than, but just greater than and not greater than or equal to, the dot remains open. When it's greater than or equal to, we close it. When it's greater than or it's just less than, we leave the dot open. X is greater than 35 over a half, or 35 over 2. Make our little dot at 35 over 2, which is obviously to the right of 0, and then we draw a line to the right. Last one, we're going to multiply everything by 4. We don't multiply by a negative here. I'm a big fan when we try and get rid of the denominator, just multiply by the denominator as a positive number. The negative number will stay with the numerator. So when I multiply everything by 4, I get negative 3x, because the 4's cancel, and we're left with negative 3x. 4 times negative 7 is negative 28. 4 times 5 is 20. I add 28 to both sides, I get 48. And now I'm dividing both sides by a negative 3. So that means the inequality gets flipped again, and it becomes x is less than negative 16. When I go to graph it, it's an open dot over the negative 16 because it's just a less than. And then we draw the arrow to the left. And that's how we solve inequalities.